This video covers everything that we worked on in class today on Monday, December 6th in 8th grade honors math. We're going to start with the do now. Today's do now is working on adding and subtracting positive and negative numbers. So go ahead and start by pausing this video and completing the do now, and then come back when you are finished with questions 1 through 5. So it can always be helpful when we're working with positive and negative numbers to have a number line to reference. On your desks at school, there are number lines there for you to use. And even if you only draw a piece of the number line that you might need or that you might want to use for a given problem, it's really instructive to see the direction that our numbers are moving in and just to be able to compare those positive and negative values. So for example, in question 1, when we start with -6 plus 3, we know that we can add 3 moving right. So when we're adding a positive number, for example, starting over here at -6, we're moving 1, 2, 3 spaces right, and we end up here at -3. And then in question 2, when we start at +8, we know we're adding -4, which means we're moving left. We're moving in the negative direction. 1, 2, 3, 4, and we end up at +4. -3 minus 2, we start at -3, and we move left because we're subtracting 2, and so we end up at -5. The next 2 questions don't show up on our number line, but you can imagine that if you did have a number line to demonstrate these points, you would have -12, and then you would be moving 5 spaces in the negative direction, which would bring you to -15, or -17 rather. And then it's the same thing with -18. In -18, we're actually doing 2 rounds of subtraction here, but if you can imagine -18, we're taking away 3, 1, 2, 3, which would bring us to -21, and then we're taking away 5 more, which brings us to -26. This week's foundational learning target is to be able to solve problems involving negative numbers and all 4 operations. We'll keep practicing throughout the week, so if you are absent, make sure you're watching these Do Now videos closely so that you're ready for that foundations quiz on Friday. Okay, today's learning target, kind of our core lesson for today, is I can find the rate of change of a linear relationship by figuring out the slope of the line representing the relationship. And so we're going to focus on 5.2 and 5.3. We're going to skip 5.1. So go ahead and head to slide 3. This is going to be slide 3 on your Classkick. And I want you to take a look at 5.2. So pause this video and spend at least 5 minutes trying to figure out how many cups you need for a stack with a height of 50 centimeters. Take 5 minutes and pause this video. So one thing that might have been helpful to try, hopefully you've given this a try on your own, is to look at a table. We know that we have a relationship between cups and heights. And more specifically, we know that when we have 6 cups, our height is 15 centimeters. And when we have 12 cups, our height is 23 centimeters. So right off the bat, we can tell that our relationship is not proportional. Because while 6 times 2.5 equals 15, 12 times 2.5 does not equal 23. So we know we do not have a proportional relationship. But what we need to figure out is every time you add a cup, so 1 cup here, we add another cup here, we add another cup here, each of these lines that I'm drawing in rainbow, how many inches are we adding to the stack? Because once we figure out how many inches, or I should say centimeters, because we're working in centimeters, but once we figure out how many centimeters we get from each cup, we can determine how many cups we need to add to get 50 centimeters. Well, let's take a look at our table. When we add 8 centimeters, we needed 6 cups. So if I know that 8 centimeters is equivalent to 6 cups, I know that 1 cup is just 8 divided by 6, just an equivalent ratio problem, right? And 8 divided by 6 is the same thing as 4 over 3 centimeters. And the reason is because 8 over 6 equals 4 over 3. We just divide 8 by 6. So I know that 1 cup gives me 4 over 3 centimeters. And so here I need to add 27 centimeters to get to 50 centimeters in total, which means that I need to know 4 over 3 centimeters is 1 cup. So how many cups do I need for 27 centimeters? Well, I got to figure out what I multiplied 4/3 by to get 27. So 27 divided by 4/3. And that is equal to 20.25. And so I need 20.25 cups. And we're not going to do partial cups. And so we'll just say that we're adding 21 cups for a total of 23 cups. And if I add 21 cups, then I'm actually adding 28 centimeters because 21 times 4/3 is actually 28. And so I end up at 51. But I can't ever end up at 50 because we don't add partial cups. And so for a stack with a height of 50 centimeters, you need 23 cups. Now, let's explore this relationship a little bit more by plotting the points in a table. You can reference this table to help you. I want you to go ahead onto slide 4. Go to slide 4. And I want you to plot the points. Pause and plot the points. I'm going to go back to slide 3 on my screen and zoom in on the table just to help you plot the points. So there are the points. You can pause this video and get to plotting those points. Okay, so your graph should look something like this. We know that for 6 cups, we've got 15 centimeters. For 12 cups, we've got 23 centimeters. And we know that to get to 50 centimeters, and again, it's actually 51 centimeters, we needed 23 cups. And so if I go over to 23, and I'll trace up just to about 50 here. And then I can draw a straight line through my points. See if I can get a straight line on the first try. Not the best straight line. It's a little tricky for me on here, but you should have a straight line through your points. It's actually a lot easier on Classkick than it is for me on my tablet, but this is a straight line through the points. I'm just having a little trouble drawing it. Let's see. There we go. It's not perfect, but it is a straight line. So what are some ways that you can tell that the number of cups is not proportional to the height of the stack? Well, there are 2 main ways. One is it does not intersect the origin. And a graph of a proportional relationship always intersects the origin. The origin, remember, is 0, 0. So that's the first way. The second way is that the coordinate pairs of the graph are not equivalent ratios. What do I mean by that? Well, this point here is 6, 15, and this point here is 12, 23. And while we can multiply 6 times 2 to get 12, 15 times 2 does not equal 23. And so we know that this is not a proportional relationship because we can't multiply x and y by some constant to produce the other value. Another way to think about it is that 12 and 6 can't be multiplied by the same thing to produce the y. So the coordinate pairs are not equivalent ratios. Now, even though this is the case, even though they're not proportional, we can still find the slope, because if we look at the triangle that we get here, we can still find a base and a height, and that's all we need to calculate the slope. So in this case, the base is 6 and the height is 8, because I'm going from 6 to 12, which is 6, and then I'm going from 15 to 23, which is 8. So the slope is y over x, which is 8 over 6, which is actually 4 over 3 simplified. And 4 is our y value, it's centimeters, and 3 is our x value, it's cups. So it's 4 over 3 centimeters per cup. Now, that intersection with the vertical axis in question 4 tells us the original height of the cup. It's the starting point. The original height. And that is 7 centimeters. The coordinate pair is 0, 7. It's 0 spaces side to side and 7 spaces up. And then every time we add a cup, we're adding 4 over 3 centimeters per cup to the stack. So notice that even though this relationship is not proportional, even though we can't multiply x times something to get y every time, it's still growing at a constant rate. For each cup we add, we're adding the same amount of height. And that's the key takeaway from today's lesson. There's another example here on the final slide about babysitting. You have someone who starts babysitting and they charge $10 as their starting price. And so the relationship's not proportional. It doesn't intersect 0, 0, but there's still a constant rate of change. On the final slide today, in the main folder, you have in the main folder, not on the final slide. In the main folder for today's class, you've got an exit ticket. So be sure to check that out. Once you have finished your exit ticket, your final step will be to work on tonight's homework, which is also in the main folder. As always, if you have any questions, please make sure to send me an email.